Well, good afternoon and welcome everyone to today's webinar, which is hosted by the Regional Fire Science Consortia of the Upper Midwest. I'm Craig Meyer. I serve as the coordinator of the Tallgrass Prairie and Oak Savannah Fire Science Consortium. Jack McGowan-Spinsky is also with us today. He is the program manager for the Lake States Consortium and will be moderating today's webinar. Thanks for joining us. If you haven't had a chance to fill in our one-question survey, please take the opportunity over the next few minutes while I introduce the presentation. Today we have an opportunity to learn more about the National Weather Service and the fire weather forecast from meteorologist and forecaster Casey Sullivan. For those of you who may be joining us for the first time, let me give you a little more background. Both organizations are funded by the Federal Joint Fire Science Program and are two of the 14 regional consortia across the country. Our mission is to accelerate the awareness, understanding, and adoption of wildland fire science information by federal, tribal, state, local, and private stakeholders. The Tallgrass Prairie and Oak Savannah region covers portions of 11 states, which stretches from southern Michigan and central Ohio to the eastern Dakotas and Kansas. The Lake States region includes parts of Michigan, Minnesota, Wisconsin, and the adjacent Canadian provinces of Ontario and Manitoba. The consortia strives to be inclusive and neutral science partners working to foster collaboration among researchers and practitioners, organizations and individuals, and by developing innovative approaches to science delivery while facilitating dialogue about new science findings and emerging needs. Before the presentation begins, I'd like to take a moment to explain our webinar interface, which uses Adobe Connect. First, if you would like to ask a question of Casey or interact with the other attendees, please use the chat box, which is located in the lower right-hand portion of the screen. Once you type your question, just click the send button. Jack and I will be monitoring these questions and we'll make sure that there's an opportunity for Casey to address them. Second, for the best resolution of the presentation, please maximize the webinar window on your computer. Today's speaker is Casey Sullivan. Casey is a meteorologist with the National Weather Service Chicago office located in Romeoville, Illinois. He is the fire weather program manager and acts as the liaison between the staff at the Chicago office and the local fire and land managers. Thank you for presenting, Casey.
Sure, and thanks for inviting me. Appreciate it. Today's presentation is kind of in two parts. I'll be talking about the National Weather Service, a little bit about who we are, and the forecast that the National Weather Service offers. And then the second half of the presentation will be discussing the different fire weather parameters that are most critical when you're going to be doing a prescribed burn or in the event of a wildfire. Obviously, there's several parameters that are important to prescribed burning and wildfires, but I'm going to touch on some of the more critical elements in today's presentation. The National Weather Service is a federal agency. We're part of NOAA, the National Oceanic and Atmospheric Administration, which is part of DOC, the Department of Commerce. So your tax dollars fund the National Weather Service. Our mission, the reason why we exist, is for the protection of life and property. So our job is to warn everyone, the citizens in the United States, of any potential weather hazards that are going to be a threat to their lives or a threat to their property. And so everything that we do is geared towards that mission of protecting life and property. The National Weather Service has 122 what we call field offices, and they are staffed 24 hours a day, 7 days a week, 365 days a year. There is always someone at every Weather Service office. Christmas morning, Thanksgiving afternoon, New Year's Eve, we're here. Each office has approximately 25 staff members. It varies a little bit. Here at the Chicago office, we have a few additional forecasters. There's approximately 10 forecasters per office. We have 13 here at the Chicago office, and we all work rotating shifts. So I ended evenings yesterday, and I'll start midnights tomorrow night. And we will rotate like that through the course of a year. We're constantly rotating through our schedule. The Weather Service offices have what we call a county warning area. So each of those 122 offices is responsible for a specific geographical location, and we call that our CWA. In that area, we are responsible for everything. Watches, warnings, advisories. We do river forecasting, all aviation forecasting for those offices that are near bodies of water, such as the Great Lakes. We do marine forecasts. Most offices are responsible for what we call their nearshore waters. Here at the Chicago office, we forecast for the open waters of Lake Michigan, so we do all of Lake Michigan. Each office also has their fire weather forecasts, so they're responsible for all the fire weather forecasts for that area. And for those of you familiar with NOAA Weather Radio, each transmitter that's located inside the county warning area, that information broadcasts from that local National Weather Service office. So we have 11 transmitters in our area, and the broadcast originates from our office in Romeoville, and it goes out through phone lines to the actual transmitters. So all of the weather radio transmissions that you hear, they originate from your local National Weather Service office. Here's a map of what we call Central Region. The National Weather Service is broken up into 6 regions. There's the Alaska and Pacific region, but in the continental United States, there's 4 regions, Eastern, Southern, Central, and Western. And so if you're interested in going to one of our web pages, you see on the top there, our web page is weather.gov. And then if you wanted to go to an individual office, all you do is just replace that word city, I have highlighted in red, with the office that you want to go to. So it would be weather.gov/Detroit, weather.gov/Chicago, whatever office you want to go to, just replace the word city with the city name. And you can see how each office has their own area of responsibility. So in the Chicago office here, we forecast for 18 counties in northeast Illinois and 5 counties in northwest Indiana. And if for some reason we were unable to provide forecasts for our area, in one of those rare cases where a strong storm or a tornado is bearing down on an office, sometimes we have to do computer upgrades or software upgrades. We have what we call service backup. So if we couldn't provide forecasts for our area, the Lincoln office and the Milwaukee office are able to back us up. They would take over our responsibilities. Likewise, like if the Lincoln office couldn't provide their services, we would back them up. So there's contingency plans in place so that if something were to happen to an office, whatever that case may be, our office was struck by lightning in July of last year. And so we were in severe weather. We were issuing tornado warnings and severe thunderstorm warnings. And we had to hand all that off to the Lincoln office while we tried to reestablish communications and determine just how severely we were hit by lightning. So there are contingency plans in place so that if an office is unable to provide the forecast, another office will pick up those responsibilities. I'm getting a little bit more specific, though, into the fire weather program. Again, I'm what we call the liaison, the fire weather program manager. It's my job, in addition to providing forecasts on a regular basis on my when I'm working the operational shifts, in addition to the operational work that every forecaster does, the forecasters have program areas. And so I work with the various fire and land management and agencies in Northeast Illinois and Northwest Indiana. And I act as the liaison between them and our office so that I bring new information to them and I bring their information back to the forecasters here at the office. The Fire Weather Program Manager coordinates changes, provides information and training, and is the point of contact. The Fire Weather Program Manager, such as myself, also has additional training and experience. There's a S591 course that is specifically geared towards fire weather program managers that I've taken. I've taught the weather units of the S190 and S290, and I also go out and conduct outreach, such as this webinar. and go out to meetings, and I meet with our local fire and land management agencies. So I'm kind of the point of contact to foster a partnership and relationship between our office and the various fire and land agencies. The fire weather program also has what's called an incident meteorologist. Oftentimes, the incident meteorologist at an office is also the fire weather program manager, but that's not always the case. The incident meteorologist has even additional training and education experience above what a fire weather program manager would have. I am not an incident meteorologist. We have several that are dotted across the country, and when there's a wildfire, or in some cases if there's some type of incident that requires weather support, they're dispatched to that command center, and they provide the commanders there, the incident commanders, with the most up-to-date weather information so that they can make their decisions. And so, as I noted, it's really important to build that partnership and that relationship with your local National Weather Service office and your fire weather program manager, and invite them to come out to see a burn. We have a real good working relationship with the Indiana Dunes here in Northwest Indiana, and it's always a challenge between the weather and our schedule to get forecasters out there, but whenever it works, we do. And I understand, some agencies have policies in place that if you're not certified to be on the fire line, then you can't be on the fire line, and we understand that. But for those agencies that are able to have people out on the fire line, it's really helpful and useful for our forecasters to gain that knowledge of just how important the forecast is to your operations. And invite fire weather program managers to come out and present at meetings or symposiums, or just to sit down and discuss the forecast with your local crew. You can ask for a tour of the National Weather Service office. I realize, that some of the offices are quite a ways away. You might be an hour or two drive just to get to a Weather Service office. But if it's something that you're able to do, it's probably worthwhile. And if the forecasters, and it doesn't necessarily have to be the fire weather program manager, but if you schedule that tour and you ask, sometimes tours just last a half an hour or 45 minutes, but if you have the time and the staff of your local office has the time, you can ask to sit down and say, can we get a little bit more than just a tour? Can you guys show us, how you actually come up with the forecast and the things that you look at for the forecast? So these are all opportunities and ways to build that partnership with your local National Weather Service office. Getting into the fire weather forecast, there's a lot of variability across the National Weather Service, and there's a reason for that, and it's because the fire weather forecasts are really tailored and geared towards their local users. So the time of year, whether or not your local office produces fire weather forecasts year-round, or just during the burn seasons, or just during the warm season. Here at the Chicago office, we would normally start on March 1st. It's been so cold and snowy, we delayed that to March 15th. And then we'll end on May 15th. There really isn't a great need for fire weather forecasts in this area during the summer months. A few years ago when we were in the drought, there was a need for fire weather forecasts, and so we continued during the summer months. So it's important to know when you can expect fire weather forecasts from your local office. Generally, the detailed information, the really specific information, which we'll talk about coming up, is only available between 36 and 48 hours. And so it's important to know how far out you can get that detailed information. Available parameters, some offices pretty much put every single parameter available on their forecast, whereas other offices only put certain parameters. So it's important to know what you can expect from your local office. Units, in specifically winds, whether they're using knots or miles per hour, and whether or not they can adjust that or add a different unit. Also, meters per second is another unit for wind speed. So it's important to know what wind speed you're getting and what wind speeds are available. The ventilation and scale, or the ventilation scale and ranges, and we'll touch on that coming up. It's important to know how they're putting their ventilation and dispersion index on their forecast. And also red flag criteria. That varies by office as well. And again, it's usually because of local needs. Some users need different values. Some values are more critical to them in their region of the country than in other areas of the country. So all of these pieces of information regarding the fire weather forecast from the National Weather Service can vary office to office, and so it's another reason to build that relationship so that you know what to expect and what you're getting from your local office. The routine daily forecasts are generally issued twice a day, usually once in the early morning and once in the mid to late afternoon. That's kind of how the forecasts are done at the local offices. We generally will do a complete overhaul of the forecast on the midnight shift, and so that's available to everyone when they wake up in the morning when all the TV meteorologists get on the air. And then we'll do another large overhaul to the forecast during the afternoon, and so that's available in the late afternoon when everyone is heading home and all the TV meteorologists are going back on the air. But we're getting computer model data on a regular basis as computing power increases, and we're learning more about the computer models. We're constantly getting new data, so it's not like we don't have new data and we're not updating the forecast. We are on a regular basis. But those are the two big pushes of new information. And so that's generally when the fire weather forecasts are updated. Here in the Chicago office, we update the forecast about 10:30 in the morning. And I told our forecasters to just focus on the today period, because that's really what the reason for that update at 10:30 is because that's when everyone is getting, if it turns out to be a day to burn, that's when everybody's getting out there and is starting to light their burns. And so we want to try to get the most accurate, up-to-date information out there in the late morning. The daily forecast, the routine forecasts are also county-based. And so in the Chicago area, and for that matter anywhere near a lake, in the spring and summer with lake breezes, you're getting wind speeds and wind directions that are averaged over a very large area. And so that can be misleading. And so it's really important that you look at our hourly weather graphs to get the most precise information for your location. The daily forecasts are a good way of saying, okay, tomorrow it's going to be rainy, the mixing height's going to be low, it's not a good day to burn. It gives a good overview of what we're expecting for that county. But to really, if it turns out that it's going to be a good day to burn, if you really want to go to our hourly weather graphs and look at the specific information for that grid point. One of the things that the daily forecast also has is a discussion on the top, and I've tried to get our forecasters to try to get away from high pressure, low pressure, and actually try to talk about what the mixing heights are going to do and what the wind speeds are going to do and what the relative humidity is going to do. The discussion is supposed to be an overview of high pressure, low pressure storm systems, cold fronts, warm fronts, and obviously frontal passages are important. But I've also tried to get them to include a little bit more about the actual fire weather aspect of the day. You know, mixing heights today should, easily get above 2,000 feet. Relative humidities today could drop into the 25 to 30% range. So I try to get them to put a little bit more of the fire weather aspect of the forecast in that discussion. And so that discussion could be of some value depending on what information the forecaster includes in the discussion. And as I mentioned, the hourly weather graphs is really where you want to go to get the most up-to-date specific information for your point. We do put things like lake breezes in our forecast, and so lake breezes are difficult to forecast, but you will see that change from westerly at 6 miles an hour to easterly at 10 miles an hour. The timing might be slightly off, but we do our best to get that specific information in there, whereas if you're looking at a county forecast, it might say west at 5 in the morning, east at 10 in the afternoon, and that really doesn't tell you when that wind shift's going to occur or perhaps the specific direction if you need a specific direction. The routine fire weather forecasts are based off the data that you find in the hourly weather graphs. It's just they average all those grid points together. The grid points are roughly 2.5 kilometers by 2.5 kilometers, so it's a pretty small scale. The hourly weather graphs provide temperature, dew point, relative humidity, wind speed, wind direction. All of that information is available out 7 days. So here at a local National Weather Service office, we forecast out 7 days. You might be surprised to learn how many requests we get for information beyond 7 days, not necessarily from fire weather users, but just from the general public. We'll get questions about, you know, we're having next month, what's the weather? I'm having a June, what's the weather going to be? Here at the local office, we just forecast out 7 days. And we really, when there's ongoing significant weather, in this case, and being still March in an active winter, you know, when we have winter weather headlines out, we're really focused on the next 1 to 3 days. And so while we are looking at days 4 through 7, we're not putting as much emphasis on that extended period, that days 4 through 7 or 5 through 7, as we are over the next 1 to 3 days or 1 to 4 days. Likewise, if there's a large storm system that's going to affect us, say in the days 2 through 4, we might not be putting as much emphasis on the short term if there's nothing going on. We might be really focused on that big storm approaching in the day 2 to 4 period. For the fire weather parameters, however, the hourly weather graphs are only going to show that data out 36 or 48 hours, depending on how far out your local office goes. So you can get the temperature and dew point relative humidity out 7 days, but the transport winds, mixing heights, that data is only going to be available out 36 to 48 hours. And like I said, it's a much more detailed forecast, and you really want to use the hourly weather graphs for specific trends through the day. Here is an image of our hourly weather graphs. And I grabbed this back in January from the Springfield, Missouri office because we're not currently doing fire weather forecaster at the Chicago office right now. This data would not be available on the hourly weather graph because we're not producing this data. And what you see here is the hourly weather graph is a very large graph. When you see it, you'll have to scroll down to it to get to the fire weather parameters. They're at the bottom of the page. But on the first one here is the mixing height, and you'll see how the mixing height goes down here during the nighttime and then increases during the daytime. In the hourly weather graphs, you can see this area here is shaded in a light gray, and that's nighttime, and then the white is daytime. And those shades of gray and white change based on the sunset and sunrise times. And so then as we go into the evening hours, the mixing height comes down, and I think the reason, I don't know off the top of my head this particular event, but I think the reason why the mixing height came back up here during the overnight was there was a cold front passage. And so typically, even at nighttime with a cold front passage, you get a lot of mixing behind the cold front. So you can see the mixing height trend here by hour through the course of the day. And then there's the Haines index, which I'll talk about when we get into the fire weather parameters. It goes on a scale of 1 to 6. The transport winds, in this case, the Springfield office uses knots. And on the hourly weather graphs, you can change the units between knots and miles per hour depending on what you're most familiar with or comfortable with. And then there's the ventilation rate here at the bottom. And one of the I guess, disadvantages to the hourly weather graph, specifically with the ventilation rate, is if you look over here, it says times 1,000. So the ventilation rate here, where it says 45 in the afternoon, you have to multiply that by 1,000. If we didn't do this, the scale would be very large, and we wouldn't be able to get it in kind of a condensed format here for the hourly weather graph. So you just want to make sure that you look over here, and the same thing for the mixing height here. You have to multiply it by 100, so this would be 2,500. One of the other nice things about the hourly weather graph is when I grabbed the screen capture, I had the cursor on 3 p.m., and so I'll move the little green arrow here to 3 p.m. And down at the bottom of the page here, it says Sunday, January 26th at 3 p.m. And so it gives you all of the information at that time. So the graph is going to extend above the mixing height here. You'll see temperature, dew point, relative humidity. But if you wanted to see, well, what's it going to be at my ignition time at 11 a.m., you can put your cursor at 11 a.m., and then all of that information is going to be here at the bottom of the page. As you were to scroll across a live hourly weather graph on our webpage, all that data at the bottom of the page would be changing. It wouldn't be static like it is in this capture of 3. One of the other things to mention about the hourly weather graph is the hourly weather graphs they don't exist until you click on our web page. So when you go to weather.gov/Chicago, you click on our web page. On the lower right-hand corner of that web page is how you access the hourly weather graphs. Those hourly weather graphs don't exist until you actually click on a point. And so when you click on the point, it's like a request that you send to the database to say, go get this information for this grid point. And then the hourly weather graph is then generated. So if you want to keep this information either for your burn plan, for your report, or you want to see how it changes. For example, you're looking at tomorrow afternoon and you want to see how it changes. Well, when we send a new forecast, this data is updated automatically. There's no way to go back and look at the previous forecast on an hourly weather graph. You can certainly go back and look at the text forecast, the routine forecast, but there would be no way of going back and looking at what we had forecast in the hourly weather graph. And so if you want to have a record of this information, you'll want to either grab a screen capture or go ahead and print it out. There's no way to go back and look at previous data on an hourly weather graph. The Fire Weather Watch and Red Flag Warning Program, again, it kind of going along that topic of our mission of protecting life and property. It's when a fire weather watch would be issued out as far as 96 hours in advance. A warning would be out as no more than 48 hours. And it's basically saying there's a combination of dry fuels, low relative humidity, and strong winds, or some combination of those, that is going to produce very critically dry conditions that could lead to wildfires. But it's important to note that our forecasters need feedback from all of you in the field. Sometimes we could be really windy and really low on the relative humidity, but the fuels aren't that critically dry. So the information that you can provide to your local weather service office when we're in one of those critical fire weather red flag watch days is very important. The more information the forecaster has, the better decision that he or she can make in terms of saying, okay, we really need a red flag warning today, or, you know, we're kind of right on the edge and our crews say that we probably are okay, and so we're not going to issue one for today. The criteria varies by office, and so I can't emphasize this enough. You really need to make sure you know what your local criteria are. But as an example, here in the Chicago area, we use a 20-foot wind speed of 20 miles an hour or higher, afternoon humidity of 25% or less, and 10-hour fuel moisture of 8% or less. And to get any one of these criteria by itself is relatively easy to do. Probably the most difficult is to get the relative humidity down below 25%, although that does happen from time to time. But getting these three to at the same time is fairly rare. On average, I would say we probably do one fire weather watch or one red flag warning a year, except I believe it was 2012, the drought year. I think we did 9 red flag warnings that year, and that was the most red flag warnings that we had done in any year, and I think it was the same as what we had done as a combined over the previous decade. So I think since I got here in 2000, we had probably only done 7 or 8 red flag warnings up until 2012, and then we ended up doing 9 in 2012. So they're fairly rare events, at least in the Chicago area, and unless, of course, you're in a drought situation. And again, a very important point here, these are the criteria that we use at our office in our area. you need to make sure you know what the criteria are from your local National Weather Service office. And then the final forecast that the National Weather Service does is a spot forecast, and it's a site-specific, user-requested, all done online, and it can be requested for a prescribed fire, a wildfire, a hazmat situation, or a search and rescue situation. Those are the 4 reasons that you can request a spot forecast. And we occasionally do get spot forecasts from non-fire agencies. There was a train crash in northwest Indiana a few years ago, and the emergency manager there was requesting spot forecasts for a couple of days because he had all of his people out there working at the crash site. We've also gotten spot forecast requests for large outdoor events. So the vast majority of spot forecast requests are for prescribed fires, but we do get them for other events. There's the National Weather Service operates under what's called directives that allow us to do things or allow us not to do things. And so the directives go into much greater detail about who can request a spot forecast. And so if you're uncertain as to whether or not you can request a spot forecast, you'll want to get in touch with your local National Weather Service office and ask them before requesting the spot forecast. And also you can reference the directives online. But in general, any federal agency can request a spot forecast for any reason. Any agency where federal resources are involved can request a spot forecast, or when public safety is involved. So if you are the person that is responsible for the burn, if something were to happen, you would be the go-to person. You are the person that is ultimately responsible. If that burn boss says that I need this spot forecast for public safety, then we can also do the spot forecast request. But again, it's important to contact your local National Weather Service office if you have any concerns about whether or not you would be allowed to do a spot forecast, and ask and double check and make sure that you can request a spot forecast. So that's kind of the first part of the presentation. To talk about the National Weather Service, who we are, what we do, and focus on the fire weather program. And so the second part of the presentation is to talk about some of those weather elements that are a little bit more critical to prescribed burning and wildfire. And so I'll just touch on these, and if there's any questions, we can get to them towards the end. We'll touch on surface winds, mixing heights, transport winds, the ventilation rate, and the Haines index. When you're talking about a surface wind, it's really important to know what height you're talking about. There's several different heights in fire weather for surface, what could be called a surface wind. You have your mid-flame, you have your eye level, you have your 20-foot, and then you have your 10-meter wind, which is roughly 33 feet. And the reason I mention the 10-meter wind is because in meteorology, the definition of a surface wind is the 10-meter wind. When you see the wind, the current weather conditions at your local airport, it says west-southwest winds at 14 miles an hour, gusting to 21 miles an hour. That wind observation is taken at 10 meters. All over the planet, the definition of a surface wind is a 10-meter wind, 33 feet. So it's important to know that the observations that you're seeing from airports are at 10 meters. But it's also important to know that that's where we forecast. The National Weather Service forecast is at 10 meters. So when you see our forecast and it says today southwest winds 15 to 25 miles an hour with gusts to 30 miles an hour, that wind forecast is for a height of 10 meters, or roughly 33 feet. So if you don't see the height of the wind forecast on your forecast, you need to assume that the forecast is for 10 meters, that the surface wind that you're seeing, the forecast, is for 10 meters. Now, if you're looking at a forecast from a private company, or you have a contract with a private company, you'll want to ask them, hey, is this forecast at 10 meters? Is this forecast at 20 foot? If it doesn't specifically say. But as a general rule of thumb, if it doesn't say what the height of the wind forecast is at, you need to assume that it's a 10-meter wind. In the National Weather Service, all of our wind forecasts are for 10 meters, unless it's specified as a 20-foot wind, which we do both on our hourly weather graphs and our fire weather forecast, as well as a spot forecast. And we use a general rule of thumb of a 20% reduction in from our surface wind of 10 meters to our 20-foot wind. And that is, that's what all of our 20-foot wind forecasts are at. In strong cold air advection situations where you have a powerful cold front coming through in October or November, that reduction might be less. More of that wind might mix down to the 20-foot level. So your reduction might be 10 or 15%. Whereas in a strong warm air advection situation, which we're going to have over the next month or two as we start to melt the snow and we get warmer air moving in from the south, it's harder for those stronger winds to mix all the way down to the surface. So in a strong warm air advection situation over either snowpack or cold ground or frozen ground, the reduction might be more like 25%. So even though we here locally use a 20% reduction, there is variability to that 20-foot wind reduction. And that's a question that you'll want to touch base with your National Weather Service office and ask them, well, what do you use to get down to your 20-foot wind from your surface wind forecast? The mixing height is, the definition of the mixing height is just the level at which the smoke will rise before it starts to spread out. The mixing height can also, another word for the mixing height is inversion. Perhaps if you've heard the term a cap when we're talking about severe weather, you know, we're expecting severe weather to develop today, but the cap is strong and it's not preventing the atmosphere from destabilizing. It's the same thing. That cap that prevents severe weather from developing is the same thing as a mixing height or inversion. It's stable air in which the temperature warms with increasing height. So the cooler air below the inversion can't rise any higher because the air above it is too warm to let it rise. And so as the smoke is rising from a wildfire or for your prescribed burn, it gets up to this warmer layer and it just can't go any higher and it starts to spread out. And so the inversion, the mixing height, it acts as a lid to prevent the amount of vertical motion from the smoke from the fire or the wildfire. In our forecast, they're expressed as feet above ground level. Typically speaking, the mixing height is going to peak during the early to mid-afternoon, as you saw in that example. The hourly weather graph example I showed a few slides back. There are times where the mixing heights are high at night, for example, behind a cold front, or if we're expecting some type of severe weather. But generally speaking, for your purposes of doing prescribed burning, the mixing height is going to peak during the early to mid-afternoon. Sometimes the mixing height can be right at the surface overnight. In some of these very cold mornings that we've had where the temperature is, we've got a large high pressure sitting on top of us, temperature is 10 or 15 below zero, the mixing height is basically right at the surface. If you look at the exhaust from your vehicle, that smoke just leaves the exhaust pipe and just hangs right on the ground, that means the mixing height is pretty much right at ground level. Kind of the industry standard that everyone is looking for is 1,700 feet. If it's below that, depending on the size of your burn, that's usually not a good, that's usually not high enough to get the smoke, enough dispersion to get the smoke away from your area. But again, you know, it depends on what you're doing. If you're just burning along a bike path or you've got like a half an acre to burn and the mixing height is 1,500 or 1,600 feet, you know, that might be sufficient for you to do that small amount of burning. But for typical larger burns, most users are looking for 1,700 feet or higher. And it's important to note that the mixing height, as you'll see on the hourly weather graphs as you look at them, it may only, that peak of, say if we're looking for a forecast, a peak of 2,500 feet for the day, you say, oh, that's a pretty good mixing height. That may only last for a couple hours. It may take until noon or 1 p.m. to get above 1,700 feet. Then it peaks at 2,500, and then it comes back down below 1,700 feet by 3 or 4 o'clock in the afternoon. So that's another reason why you'll see that the maximum mixing height on the regular routine county-based forecast is 2,500 feet. But then you go look at the hourly weather graph and you're like, oh wow, it's only going to be above 1,700 feet for 3 or 4 hours. So it's important to know exactly how long is the mixing height going to be above 1,700 feet, if indeed that's your threshold, not just what the peak is for the day. Mixing heights are relatively, I don't want to give the impression when I say easy that anything in meteorology is easy, but it's an easy parameter to forecast in terms of data availability. We have extensive data now that allows us to forecast mixing heights with some level of confidence. We have multiple computer forecast models. We have multiple forecast levels and heights through the atmosphere. And some of our data now, our computer models, are forecasting data out hourly. So we have an extensive amount of data to look at to forecast mixing heights. The problem is that we don't have any way of verifying those mixing heights. If we're forecasting the temperature at the surface, we have all of these temperature sensors all over the country that can say, okay, we forecasted a high of 52 today, this location was 51, this location was 49, this location was 53. We can go back and say, okay, we did a decent job on the forecast. It's very difficult to do that with mixing heights because it's in the atmosphere and there's just no way of measuring and detecting what the mixing height is. We launch weather balloons twice a day, but that's at nighttime or in the morning and the evening. And we also have weather sensors on aircraft. But once you get further away from the major airports like Chicago and Detroit and Minneapolis, the planes are just too high. So the data is only good for in the vicinity of the airports. So it's very difficult for us to say if we had a mixing height forecast of 2,500 feet, it's nearly impossible if we're not near an airport to determine whether or not how close we were to the actual mixing height. And then partly, too, with the forecast accuracy is we can have pretty good confidence that the mixing height is going to be a certain level today, but then cloud cover moves in. We're expecting a mostly sunny day, and it's a mostly cloudy day. Cloud cover prevents the temperatures from rising, which impacts the mixing heights. And so something as simple as just it going from a mostly sunny to a mostly cloudy day could mean that the mixing height is significantly different. And so small changes to the forecast can make large changes to the mixing height forecast. The transport winds are the average wind speed between the surface and the mixing height. So in the mixed layer, that's going to change. The depth of the mixing layer is going to change as the mixing height increases in the late morning and early afternoon and then decreases in the afternoon. And the wind speed is averaged. So it's possible that you could have a south wind at the surface and a west wind at the mixing height, and so your transport winds would be southwest. So it's important to, again, look at those hourly weather graphs and see how the wind direction is changing as you go through the course of the day and compare it to your surface wind. If your surface wind is south at 15 miles an hour and your transport winds are southwest at 30 miles an hour, then you know that your plume is going to be changing direction as it goes aloft. And that could be important if you're burning near a sensitive area that you don't want to get smoke to. It's important to know that, okay, I got a south wind at the surface, but I got a west wind aloft, and so I'm going to be pouring smoke over the area I don't want to pour smoke over. And so the transport winds, again, is important to emphasize, are average. It's the average direction, and it's the average speed in the mixed layer. The ventilation rate is just a multiplication of the mixing height and the transport winds. So to make it very simple, if your mixing height is 2,000 feet and your transport winds are 10 miles an hour, you just multiply the two together and to get your ventilation of 20,000. The units differ based on user needs, so it's important to know what you're getting from your local office. In general, the larger the number, the better the ventilation. And this is an area of future research that I've been trying to get the ball moving on. I've heard feedback from my local users here that you have strong surface winds, say, west at 25 miles an hour, gusting 35 miles an hour, and a mixing height of like 8,000 feet, which is, we can get that sometimes in the spring, and you get a ventilation rate that is excellent. But then they burn, and the smoke just doesn't go up. The smoke is just staying horizontal. It's hugging the ground. Whether it's mechanical mixing that's preventing the smoke from rising, the column just never goes up. So I've been in contact with some smoke specialists with the Forest Service. There's some researchers that I've gotten some names for, and trying to see if there's a way to get a better parameter onto our forecast that will try to give the users an idea that the ventilation may be excellent today, but it may not be a good day to get smoke lofted because the surface winds are just so strong, it's just going to push that column over. I'm encouraged by some of the feedback I've gotten from people I've talked to, but I don't envision getting a parameter onto our forecast in the short term. So it's an area of research and focus that I'll be working on, but in the short term, I don't see anything that I can get onto the forecast to help the users with this particular concern. The ventilation rate that we use here at the Chicago office is, again, you see the large numbers because it's a multiplication. So you're multiplying the wind versus the mixing height. And so some areas, and I know in Wisconsin that the range is different. I don't know it off the top of my head, but I think poor is like less than 25,000, and fair I think starts at 25,000. And again, this is where the Weather Service is in the business of providing the information. It's really up to the users to determine whether or not today is a good day to burn. I would like to get away from using the poor, fair, good, very good, excellent, and just put the number on there and let the individual user say, okay, today's a good day to burn. The ventilation rate is good for me. But for now, this is what we do, and but this scale, obviously the multiplication doesn't change, but the scale of poor, fair, good, very good, excellent changes. And so this is something that you definitely want to check with your local National Weather Service office. The ventilation rate and dispersion, again, we kind of touched on this, similar to the mixing height being, a 2,500 foot maximum for the day might only be there at 2 p.m. The ventilation rate maximum might only be there for a few hours. So if your ventilation rate is good and you're like, okay, today's a good day to burn, it may only be good for a couple hours. So it's important to check those hourly weather graphs for those trends in both the transport or the mixing height and transport winds, but also the ventilation rate, and say, wow, it's only going to be good for like a 2 to 3 hour window. Can I get my burn in that window? So again, focus on those hourly weather graphs. The Haines index is typically good for large fires, large prescribed burns, and wildfires. It's used extensively in the western U.S. But in this area of the country, the Haines index might not be as useful for smaller burns. It's a numerical value from 2 to 6, and high values of 5 or 6 mean it's dry and unstable. Low values of 2 or 3 means it's moist and stable. So the Haines index uses the temperatures and dew points aloft to try to determine how unstable is the atmosphere today. And there's no wind data in the Haines index. It's strictly a stability index. And what would be great is, and this is kind of where the research and the focus that I mentioned a few minutes ago is that it would be terrific if we could somehow marry the Haines index and the ventilation rate together. If we could somehow get the Haines index and the ventilation rate together in a parameter, I think that would be very useful. But I'm not sure how to do that yet. And again, that's an area of research and focus to try to get a parameter. But the Haines index is really good for stability. And if we could somehow get that married to something else, to come up with like a new parameter, I think that would be very useful. And the Haines index For most of the area, we use what's called the low elevation because the pressure surfaces that we use aloft might be at ground level or even below ground level as you move out into the western plains and then into the mountains. There's different calculations that are done for the Haines index. The value is still the same. It's still a value of 2 to 6. It just uses different values aloft in the atmosphere to come up with the Haines index. And finishing up here with the Haines index, as I mentioned, so these are kind of the disadvantages. It doesn't include any wind data, and so obviously wind is very important. And it's solely based on forecast information because just like trying to verify the mixing heights, it's difficult to verify the mixing heights because we don't have observation platforms in the atmosphere. It's going to be very difficult to verify the Haines index, almost impossible to verify the Haines index. And if you see large changes in the Haines index, that's primarily based on computer forecasts that are looking aloft, and so now it's going to be very dry aloft, and now it's going to be unstable, and so instead of a Haines index of 3, now we're forecasting a Haines index of 5. But because we do the grid points of 2.5 kilometers by 2.5 kilometers, those are thousands and thousands of grid points. The changes to the Haines index and the forecast for the Haines index itself is primarily computer-based. It's kind of hands-off from the forecasters. If we had to go in there and actually try to forecast it for all of the grid points, it would just be too time-consuming. So these are some of the disadvantages of the Haines index. And with that, that kind of wraps up the presentation. And I'll thank you for your time, and I'll hand it back over to Craig for questions.
Thank you. Thank you, Casey. If anyone has any questions, feel free to type them in the chat box, and we'll pass those along to Casey. One question that we had came up, one of the participants looked at the local hourly weather forecasts, and none of the fire weather graphs are showing any lines. Is this because for their region the fire weather forecasts may not have begun yet, or are there other reasons you could be encountering that problem, Casey?
I believe some of the National Weather Service offices do not have the fire weather parameters on their hourly weather graphs. And so I believe that the hourly weather graphs will show the fire weather parameters. I'd have to get online myself here and look, and I can. I would go to our webpage and look to see if they're on there. I believe they are, but there would be no data. So if there is no if there's on the top of the hourly weather graph, if there's no fire weather parameters listed at all, then that would mean that that local National Weather Service office hasn't included the fire weather parameters on their hourly weather graphs. And so in that case, you'd want to get in touch with that local office, the fire weather program manager, and find out when they'll be getting their fire weather parameters onto the hourly weather graphs. And let me just check online here real quick about that. I'm going to look at our webpage.
Okay, yeah, it looks like this is out of the Detroit/White Lake office currently.
Sorry about the delay there. I'm unable to access our web pages here. Sometimes we have internet connectivity problems in the Weather Service, so I apologize. So I'm kind of going off of memory here that if anyone has the time, I don't know, Craig, if you have the chance to pull it up, the weather.chicago page should have the fire weather parameters listed, and if you were to click on them and try to load them, they would load onto the hourly weather graph, but there would be no data available because we're not producing the data. If those parameters are not listed on top of the hourly weather graph, then I believe then they're not even providing that data to the hourly weather graphs. So that's just based off of my memory because I can't actually look at the web page. So I apologize for that. But I believe that you'll want to get in touch with your local office if you don't see the parameters listed on your hourly weather graph.
Okay, yeah, we're getting some more feedback here. It looks like the parameters are listed, but like you mentioned, the graphs are there, but they show up with no data line. So,
right, and so once we start creating data, once we start up the fire weather season for the spring and start producing that data, then the data will show up on the graph.
Okay. We have one other question here asking, where does the Weather Bureau get fuel moisture data?
Yeah, on our web page, on the National Weather Service Chicago page, we have a fire weather page on the menu on the left-hand side, and if you were to go to that, you'll see fire weather, and we have two observation points in our area. We have the Indiana Dunes and the Medway Tallgrass Prairie, and they have what's called RAW sites. I believe they stand for Remote Automated Weather System or Sensor, and they have solar radiation sensors that allow them to compute the fuel moisture, and they compute the 10-hour fuel moisture. And so our forecasters, when we get into a fire weather red flag situation, are using that data real time, and that data is very critical to their decision-making process. So those are the 2 points that we have in our local area, and other offices would have other points in their areas that presumably that they would be looking at when they're making the decision about fire weather watch or red flag warning. But to add to that discussion, however, just having 2 points in a large area isn't always representative of what the different types of fuel conditions are. So that's why the feedback from the users is really important to determine whether or not the fuels are critically dry.
Thank you, Casey. We have one more question about the hourly fire weather, and then a question about another topic after that. Do you know when the National Weather Service will start generating data for the fire weather parameters, or does that vary from regional office to regional office? Will that be different for Chicago versus Detroit?
Yeah, just one clarification there. The regional offices, there's just 4. All the local National Weather Service offices we would refer to as field offices, just for clarification there. The start time of the fire weather forecast vary, and so that's, again, another reason why it's really important to build that relationship and that partnership with your local office. What I'll do is I'll ask our local users what the conditions are and whether or not they still need fire weather forecast if we're looking to end the season, or what the current conditions are if we're looking to start the season. And so March 1st, we actually have scheduled start and end dates here in the Chicago area, March 1st to May 15th, and then October 1st to December 15th. So it's first you can check with your office to find out if there are scheduled start and stop dates. But then in a situation like this year where we're just having this long, snowy, cold winter, we have so much snow on the ground, and in addition the ground is so frozen that even though there's a few users who are trying to get some burning done right now, the vast majority of people just haven't started. And so with that information from our local users, I decided that we're not going to start until March 15th. There just isn't a need for it. And it's a little bit of a compromise too, because our office, our forecasters are still dealing with snowfall, they're still dealing with winter weather headlines, whereas typically this time of year we might not be dealing with snowfall and winter weather headlines. So the workload would increase significantly by adding fire weather forecasts to the ongoing snowfall and winter weather headlines when it doesn't appear there isn't a real need for those fire weather forecasts. So it's important to get in touch with your local office and find out when they're going to start. But for the Chicago area and for Northwest Indiana, we're scheduled to start on March 15th. But if it keeps snowing the way it is, we may have to delay that a little bit further. It's snowing here today, and we still have a solid snowpack on the ground. And so with only a few users who are saying that they would like the fire weather forecast, the workload situation is just, it makes sense to just delay it until more users are going to be needing and asking for the fire weather forecast.
Thank you, Casey. And just want to let everybody know, Casey was kind enough to provide us with a list of contact information for the field offices. And so both consortia will have links to that information when we post the recording of today's webinar. So if you're not already in touch with your field office, we'll have contact information there for you. One other question here that we had, looking for more information about lake freeze during burn season. How strong can it be, and how far does it go in?
I'm sure, and you know, I'll be honest, you know, I'm going to speak towards the Chicago area because I'm not familiar with lake breeze generation off of Lake Huron and Lake Superior and Lake Erie. We're focused here on Northeast Illinois and Northwest Indiana, so that'll be my example, and hopefully that'll provide useful information. What we've determined over the course of time is that the lake breeze isn't so much generated by the fact that the water temperature is cold. Obviously, if there was no lake there wouldn't be a lake breeze. But it's really the winds aloft that dictate whether a lake breeze will form and how far inland it will move. And so we're usually looking at wind speeds in the 2,000 to 5,000 foot level aloft. And if those wind speeds are less than 10 miles an hour, we're pretty confident that we're going to get a lake breeze. How strong those winds are then will determine whether or not how far inland the lake breeze moves. If those wind speeds are in the order of 4, 5, 6 miles an hour, that lake breeze is probably going to move inland, and it's probably going to move inland pretty far. When wind speeds start to really go to drop off, like when there's a high pressure area moving across the area, those lake breezes can plow inland. It's rare, but I've seen lake breezes in this area reach the Quad Cities before they dissipate. Lake breezes are driven by the warmer temperatures over land and the cooler temperatures over water. So even though you need the wind aloft to be light to get the lake breeze to form, you also need the sun heating up the land, letting that air rise, and as that air rises, the colder, denser air over the lake rushes in behind it. Now, if the wind speeds are too strong, that process is interrupted by the wind speeds and it can't happen, and so you don't get a lake breeze. But in optimal situations, those lake breezes can move 20, 30, 40 miles inland. The difficult part sometimes is whether or not the wind direction. If there's a wind direction that is south or southeast here in the Chicago area, the lake breeze might just hug the Indiana shore, and it might flirt with the Indiana shore all day and then move inland and flirt with Midway and then flirt with O'Hare and then move further inland as you get up into Wisconsin. Lake breezes just aren't a big problem for fire weather. They're a huge problem for aviation. There's been times where there's 2 or 3 hour delays at O'Hare Airport and there's not a cloud in the sky, and it's just simply because of the wind direction from a lake breeze. So lake breezes and lake breeze forecasting is very challenging from a number of aspects. But generally speaking, what we look at is the wind speeds aloft in that 2,000 to 5,000 foot range, and how strong they're going to be, and then what the direction is going to be. That's usually what we're looking at for breeze formation, and then how far inland they're going to move.
Looks like we might have one follow-up question to that coming. Oh, well, thank you, Casey. I think we'll take one more question, and then we'll wrap up. The last question here is, given that the Haines index is not as good a measure for small burns, what would you say are appropriate Haines index measures under which prescribed burns are safe for the Midwest?
Yeah, I'll be honest, that's probably a question that I can't answer. I'm not a burn boss, and I don't go out and do prescribed burning. And so it would be difficult for me to say what value would be safe for a burn in the Midwest. That would be probably a question that would be good to ask another burn boss or another colleague in the field. Maybe somebody else on the webinar today. The range only goes from 2 to 6, and so it's a pretty small range as it is. And I want to, I guess, clarify a little bit with the Haines index. It could still be a useful piece of information even for a small burn, but I guess what I want to say about the Haines index is that you're looking at such a large portion of the atmosphere when we're forecasting the Haines index that it might not be a useful piece of information for a small burn. And a small burn, is a relative term. A small burn could be 10 acres to somebody. It could be a half an acre to somebody else. So I don't want to give the impression that the Haines index isn't important. It very well could be, but I think it becomes more important the larger the fire is. But, I'm a meteorologist. I'm not a burn boss. I'm not qualified to light prescribed burns, and so I don't want to say what would be a safe value or not.
Okay. Thank you, Casey, and thanks everyone who's online for joining us this afternoon for what I think was a very interesting webinar and discussion. And I'm going to advance our slide here. Got a little lag time here with the presentation. Okay. Well, if you'd like to review the webinar or share it with someone who might be interested but missed it, a recording of the webinar will be available on the consortium's website by the end of this week. While we're wrapping up, please take a moment to answer our concluding one-question survey. This will help us plan future presentations about the National Weather Service fire weather. And before we conclude, and sorry, this next slide is a little hidden by our poll, but I'd just like to highlight the Lake State Consortium's upcoming webinar. That will be on March 27th, and it's a joint presentation with speakers from the U.S. Fish and Wildlife Service and Minnesota DNR. The webinar is part of the Lake State's information exchange with the goal of enhancing existing understanding of disturbances, vegetation, and wildlife, and the integration of this knowledge into the management of Northern Lake State's ecosystem. The title is Characterizing Wildlife Communities of Fire-Dependent Ecosystems of the Northern Lake States and Exchanging Research, Inventory, and Monitoring Knowledge and Ideas. If you would like to learn more about the consortia, our activities, and for announcements about future events, the easiest way to do that is to visit our websites and consider joining our respective email lists. You can look for information in those links at our website, which is www.tposfirescience.org and lakestatesfireside.net. And finally, I would encourage all of you to please take the opportunity to provide us with some slightly more in-depth feedback on today's webinar. When you close the webinar window, you'll be directed to a short web-based survey that will provide you with an opportunity to tell us what you thought about today's topic. The survey information is very important to help us plan for future presentations on fire weather and other topics. And I'm just going to go ahead and post a link to that survey in the chat box as well. You could copy and paste that into your browser. That's especially helpful if you may have a pop-up blocker that could block the survey when you log off. So with that, we'll conclude today's webinar and